Hello everyone. In this video, we'll be discussing about stack operations in data structures. The contents are stack operations on push, pop, display, overflow and underflow. And I'll be discussing about stack implementation using an array and its applications. Basically, stack is represented as a linear data structure which follows a particular order in which the operations are performed. The order may be like last in first out or first in last out. Here, last in first out implies that the element which is inserted at the last comes out at first, and first in last out, which means the element which is inserted first will come out at last. There are many real life examples for a stack. Consider an example of plates stacked over another in the canteen. The plate which is at the top is the first one to be removed. That is, the plate which has been placed at the bottommost position remains in the stack for a longest period of time. So it is called as last in first out or first in last out order. Here you can see the pictorial representation of a push or pop operations in a stack. First of all, the push operations involves a such steps like before inserting an element in a stack, we should check whether the stack is full or empty. If we try to insert an element in a stack and the stack is full, then the overflow condition will be occurred. When we initialize a stack, we set the value of top as -1 to check that the stack is empty or not. When the new element is pushed in a stack, first the value of the top gets incremented, means top equals to top plus 1, and the element will be placed at the new position of the top. Then the elements will be inserted until we reach the maximum size of a stack in push operations. And then the pop operations. In this, before deleting the elements from the stack, we check whether the stack is empty or not. Then, if we try to delete the element from the empty stack, then the underflow condition will be occurred. If the stack is not empty, we first access the element which is pointed by the top. Once the pop operation is performed, the top is decremented by 1, that is, top equals to top minus 1. Like this, the pop operations and the push operations will be occurred in stack. As I discussed already, there are two main operations in stack, such as push and pop. Push means inserting an element into the stack. Pop helps to remove the most recently inserted element from a stack. Here there will be underflow and overflow conditions. Underflow happens when we try to pop an element from an empty stack, and overflow happens when we try to push more items on a stack than it can hold. Means maximum it can hold, over than that it can't hold. Such a situation is called as overflow conditions. Overflow and underflow conditions. The stack may have a limited space depending on the implementation. We must implement check conditions to see if we are not adding or deleting an element more than it can maximum support. The underflow conditions checks if there exists an item before popping from the stack or an empty one can't be popped further. In the overflow conditions, checks if the stack is full before pushing an element, which prevents an error if more space can't be allocated from the next item. You can see here there is examples for push and pop operations. In push operation, we are inserting an element into the stack, but in pop operations, we are deleting a certain element from the stack. Here is a program to implement a stack using an array. Here you can observe the program, and in this we are using header files, constants, global variables, function prototypes, uh, main function, push, pop, and display functions. In header files, there are such functions like input or output functions and library functions for memory allocation and other utilities. Constants means here in the program we are defining the maximum 5, which means constant with a value of 5 representing the maximum number of elements in the stack which can hold. And global variables represents the top of the stack initialized to -1 or array stored to stack elements. And in this program we are using the function prototypes like void push, void pop, and void display. Means here this will declare those functions like push function, pop, and display function. In main function, it initialize a infinity loop or displays a menu with a option to push, pop, or display. Reads the user's choice and statement to call the corresponding functions. Push function or void push, which prompts the user to enter an element to push onto the stack and checks if the stack is full or empty. If not full, increments stop and add the element to the stack. And pop function, void pop. It checks the stack is empty. If not empty, prints the deleted element and decrements stop. Display function, which is used as void display. It will check whether the stack is empty or not. If not empty, it prints the elements of the stack from top to bottom. The program repeats the menu and operations until the user chooses to exit. This program provides a simple command line interface for managing a stack of integers. Users can push elements onto the stack, pop element of the stack, and display the current stack or exit the program. Then the output will be like stack menu, push, pop, display, exit, and enter your choice 1 to 4 or enter element to push. Applications of stack includes evaluation expression, expression conversion, syntax parsing, parenthesis checking, string reversal, and function call. First of all, evaluation expressions means stack is used to evaluate prefix, postfix, and infix expressions. Expression conversions is an expression can be represented in prefix, postfix, or infix notation. Stack can be used to convert one form of expression to another. Then syntax parsing means many compilers use a stack for parsing the syntax of expressions, program blocks, etc. before translating into low-level code. Parenthesis checking. Stack is used to check the proper opening and closing of a parenthesis. String reversal means stack is used to reverse a string when we push the characters of the string one by one into stack and then pop character from the stack. Function call. Stack is used to keep information about the active functions or